Hi, and welcome to today's webinar, GPS and MGUE Program Update in High Dynamic Testing, brought to you by GPS World Magazine and our sponsor of the event, Spirent Federal Systems. Before we get started, I want to let you know that today's webinar will be recorded. You are currently in a listen-only mode. A recording of this webinar will be posted to gpsworldmagazine.com/webinars and will also be emailed to you tomorrow. At this time, I'd like to acquaint you with the ways you can participate during today's presentation. Please notice the Q&A panel at the left-hand side of your console. If you have a question, type it in the panel's text box and then click Submit to place your question in queue. We encourage you to ask and enter any questions you may have for our speakers during the presentation. We will address these questions at the end of the presentation during the Q&A portion. Questions submitted during registration have already gone to our panelists and may be covered during the presentation. If you experience any technical difficulties during today's event, you may use the same Q&A panel on your screen to submit your issue, and I or Assistant Producer Mackenzie Shoemaker will personally assist you. You may learn more about our speakers by viewing their photo, bio, and email address in the panel located on the upper left-hand side of your console. If you are logged into your social media accounts, you can share the webinar's title, description, and URL with your friends or colleagues using the Share This widget you'll see in the bottom left corner of the screen. Finally, at the bottom of your console, you will find a PDF of today's presentation slides, which you can download, and a link to visit the Spirent Federal Systems website. I'm Aurora Harris, Content Marketing Producer for GPS World Magazine, and I will be your moderator for today's webinar. Now I'd like to introduce you to today's presenters. Today we will be hearing from Mr. Mike Dunn. Mr. Mike Dunn, the P&T Capability Area Integrator at Space Systems Command, will be presenting in lieu of Colonel Ryan Colburn. We are thrilled Mr. Dunn could be here today. We will also be hearing from Colonel Clifford Solham, who is the Senior Material Leader for the Users Products Division within the Production Corp of the Space Systems Command. Following Colonel Solham is Jade Groen, who is the Director of Military GPS Ground and Core Programs for the BAE Systems Navigation and Sensor Systems product line. And lastly, we will be hearing from Mark Holbrow, Senior Director, Engineering and Product Development at Spirent Communications. At this time, I'll turn the presentation over to you, Mike. Take it away.
Hey, thank you, ma'am. I really appreciate it. Today I'm going to tell you about the GPS enterprise modernization. Really exciting. A lot of stuff has been going on over the last 2 years. So let me just give you go through this and share what we've been up to. For the GPS system, I think all of you are aware of it. It includes control system and user equipment. We've got outreach to virtually everybody in the U.S. government and international partners and billions of users worldwide. The impact of GPS is staggering. We support just a host of different applications, from agriculture to maritime, aviation, and communications. Let me see, constellation status. Right now we have 37 satellites on orbit, with 3 of them set healthy. The oldest vehicles are the GPS-2R vehicles. The 2RMs were the first ones to add M-code and L2C. So I know that a lot of people are looking forward to those new signals. The GPS-2F vehicles added L5, which is our 3rd civil signal, and GPS-3 adds L1C, which is our 4th civil signal. We've had very good performance. In fact, we hit a best day ever back in April, which is pretty exciting. The GPS Enterprise Roadmap basically shows a lot of the developments that are going on now. I want to call your attention to the top line, the capabilities line. With the last launch that we just put up, That makes 24 M-code capable satellites. We now have 24 L2C capable satellites as well, and 17 L5 capable satellites. So we really made a lot of progress. The top line shows all the spacecraft that are getting delivered. We were able to deliver SVO8 early, and we now have 3 vehicles that are available for launch and waiting launch call-up. We're making great progress on the control system, which is shown below that, as well as military GPS user equipment down towards the bottom of the chart. Let me talk just for a minute about the GPS-3 spacecraft. Have done a lot over the last 2 years, launching spacecraft and putting these new vehicles into operation. We've got 4 that are operationally accepted now, 5 that are operationally accepted now. The 5th one is in a test mode. We're expecting that that vehicle to be set healthy and be put into the fully operational mode here in a couple months. And like I said, we have 3 more vehicles available for launch and a couple more in testing right behind that. So we're making tremendous progress. The GPS-3F is the next iteration that provides a number of additional capabilities, and we're making tremendous progress there. We've got 4 vehicles on order and more right behind that. Expecting a first launch in 2026 or 2027 timeframe. And of course, we have a fully capable control system that's flying the satellite right now. But we're building a brand new one that will be provide advanced capabilities, especially for our civil signals. We've been launching on a version of this system called the Next Generation Operational Control System. The launch and checkout system successfully took over the launches for vehicles 1 through 5. And we just finished installing 17 new monitor stations for OCX, and we're in the process of doing test and verification activities now. That will deliver just over a year from now, and it'll go into an operational test mode. And finally, we've got a follow-on effort that we're doing called OCX-3F that will support the new GPS-3F spacecraft. That was awarded back in April, and will be a third block, basically, of the OCX capability. And that effort is going along extremely well. Let me hand it over to my distinguished colleague, Colonel Cliff Sullum. Over to you, sir.
All right, thank you, Mr. Dunn. I am Colonel Cliff Sullum from what used to be the GPS Directorate at Los Angeles Air Force Base. I am in charge of the Military GPS User Equipment Division, which now resides in the Production Corps of Space Systems Command, formerly known as the Space and Missile Systems Center. Within my division, we execute 2 major acquisition programs, the MGUE Increment 1 and Increment 2 programs. So I would like to start by talking about the Increment 1 program. As Mr. Dunn mentioned, both the satellites and the ground control system are already there to support M-code operations. With the fielding of MGUE Increment 1 receivers, our warfighters will gain access to enhanced anti-jam and increased anti-spoofing capabilities, both of which are critical to support our national defense strategy, which focuses on a near-peer or peer conflict. The Increment 1 program is a development program that demonstrates the M-code capability in 2 different form factors, a ground card, the GB GRAM-M, and an aviation maritime card, the GRAM-SM. Our acquisition strategy includes integrating these cards into 4 service-nominated lead platforms: the Joint Light Tactical Vehicle for the Marine Corps, the Stryker for the Army, the B-2 for the Air Force, and the Arleigh Burke Destroyer, or the DDG, for the Navy. While our program office is integrating into one platform for each service, this is really simply confirmation that the M-code cards are ready for fielding. For all other platforms in the DoD, the individual services are responsible for the procurement of their cards and the integration into their platforms. As I'm sure many of you are aware, the Trusted Foundry, where the Increment 1 ASICs, the computer chips, are the brains of the GPS receivers, that foundry is reaching the end of its life. Because of that, the Department of Defense, operating through the Defense Logistics Agency, or DLA, is procuring a lifetime buy of Inc. 1 ASICs to ensure that M-code is available for our warfighters until the Increment 2 program completes its acquisition program. So last month was very exciting for the MGUE programs. Our lead developmental test organization, in conjunction with both the Marines and the Army, conducted a field user evaluation of our Increment 1 M-code receivers in the Joint Light Tactical Vehicles. Although this was primarily a Marine Corps test, the Army was able to leverage the data from this FUI event and was able to remove the requirement to conduct an operational test of their Stryker lead platform. The completion of that FUI event essentially wraps up the ground card portion of the Increment 1 program, leaving just the aviation maritime card development and integration left to go. Next month will be a critical milestone for that aviation maritime card when our vendor delivers the fieldable version of software for both the B2 and the DDG. While there will still be a lot of work to do on this card, the software delivery keeps us on track for reaching our technical requirements verification and the PEO certification of readiness for operational testing for both the B2 and the DDG, which are, you can see at the bottom of this chart, are upcoming milestones for the program. I would now like to switch gears and talk a little bit about the MGUE Increment 2 program. This program is actually two distinct programs that are intertwined with one another. The first part is the development of the Miniature Serial Interface, or MSI. This effort involves the development of the next generation ASIC on a foundry line that isn't obsolete, and the integration of that ASIC into a receiver card, or the MSI. That MSI receiver will then be integrated into a joint common handheld that will replace the Dagger. At the bottom of this chart, you can see the milestones for both the MSI and the handheld. But I'd like to point out that although the handheld work isn't shown for the next few years, our program office has already started working with industry to develop prototypes of what that handheld will look like. And we've conducted a few demonstrations between our vendors and members of the operational community, including Marines, Army soldiers, Air Force special operators, that all require a handheld GPS device. These interactions with the operators have provided valuable feedback to our vendors on what the operational community is expecting in the next generation of GPS handheld. Within the MGUE programs, we have three prime contractors on both the Increment 1 and Increment 2 programs. BAE Systems is one of those contractors supporting both Increment 1 and Increment 2. So I would now like to turn it over to Jade from BAE, who will discuss some of the latest advancements in receiver technology.
Thank you, Colonel Solom. I'm going to move forward a couple slides here. Okay, so I actually would like to start my presentation with a video. So I'll go ahead and play that video now, if I can. The play button is not working.
GPS. It's the key to joint all-domain operations. But jamming and spoofing threaten to stop your mission dead in its tracks. Now, BAE Systems has the M-code solution to protect your position, navigation, and timing data. When the enemy tries to lead you off course, drive you straight into a trap, or leave you blind in the dark, BAE Systems will get you to the target and home again with the highest level of GPS assurance available in the world. So you can focus on your mission, keeping you on course and your position secure.
All right, I love that video. As I said, I am a part of the navigation and sensor systems business at BAE Systems. Many of you have probably worked with us in the past, whether it was part of Rockwell Collins or Collins Aerospace, but we are happy to now call ourselves part of BAE Systems and call BAE Systems our home. We've been part of the military GPS since its very inception over 40 years ago, and we bring these years of experience forward as we are introducing the next generation of military GPS with M-code. NSS does provide military GPS products to support all segments of the market, including weapon systems, ground products, and airborne platforms. We specialize in providing the lowest power SASM and M-code products, providing reliable, high-performing products for all of military GPS. And you can see on this slide a list of some of our highest volume products today, including the MPE, Microgram, Digger, NavStrike, NavFire, NavStorm, and Polaris Guide. But today, I'm going to focus more on the future, M-code. M-code has been in the news a lot lately, and I'm happy to say that BAE Systems has been a large part of that. I'm going to highlight just a few of the big stories about BAE's M-code GPS in 2021. Looking at the top left of this chart, BAE Systems successfully completed the first M-code FMS approval and has now delivered M-code GPS receivers to one of our allies overseas. This is a huge first step in getting M-code fielded globally. In the middle of the chart, in August, BAE Systems unveiled the world's smallest, lowest power M-code receiver with our Microgram M. This product is the same size as our legacy Microgram, about the size of a postage stamp. We're going to talk more about the Microgram M later in this presentation. And finally, on the right side of the chart, Colonel Solom gave us a small introduction into the obsolescence issues with the Increment 1 M-code ASIC. And BAE Systems was awarded a contract from the Defense Logistics Agency for $325 million to acquire those M-code GBS modules. This purchase sets the stage for Increment 1 M-code availability for the next 10 years, which is very important as we develop Increment 2 and we can keep Increment 1 M-code in the field while Increment 2 is being developed. But why do I highlight that M-code is in the news? Because I'm happy to say that in 2021, M-code is ready. M-code is ready for transition to fielding and full rate production. And I'm going to talk about 3 of our M-code products that can help you with your transition to fielding today. So first, we have the MPEM. The MPEM is fully qualified and in low rate production, transitioning to full rate production at the end of this year. This product is the same size as our legacy MPES, allowing users an easier path for integration. The MPEM and all of our M-code products are security certified with no restrictions and provide enhanced anti-jam and anti-spoof performance for both Y-code and M-code signals. So what does that mean? That means that if you field this product now, it's still going to give you an advantage even while the space segment of M-code is still being matured. The MPEM product was approved for export via FMS and is now being integrated by our allies. You can see the physical characteristics on this card, on this slide, and our contact information will be provided later in this presentation as well. So feel free to reach out if you would like to request any additional details on any of our products that I'm going to talk about. Moving on to the next product, we have the NavStrike M. This is a weapons-based product and provides several key benefits, including enhanced direct Y and M-code acquisitions, 24-channel all-in-view tracking and navigation, field reprogrammable software, and antenna masking selection, just to name a few. The NavStrike M is fully qualified and entering full rate production in 2021, and has also been approved for FMS export. Similar to the MPEM, the NavStrike-M was developed to provide backwards compatibility with our legacy NavStrike users for ease of integration and adoption. And finally, we have our Microgram M. BAE unveiled this product at the Joint Navigation Conference in August, and it is the world's smallest, lowest power M-code GPS receiver available today. The Microgram M utilizes the same CGM module as the MTEM and NavStrike-M, therefore has security approval with no restrictions. This ultra-small swap product allows for our micro GPS users to have a path to M-code that was not available previously. This product is being qualified now and will achieve full rate production in 2022. Reach out to us if you have any questions about any of these products. As I said, they are ready now, and we're excited to get the advantages of M-code and Increment 1 into the user's hands as soon as possible. Finally, on this slide, you can see that our contact information, the contact information for myself, Jade Groen, Frank Zane, our Director of Business Development, Sean Ryan, who is our on-site Space Systems Command, SSC, BD Focal, and Chrissy Littler, who is our SSC Program Management Focal. You can reach out to any of us for additional details on our products and any questions you may have, or visit the website listed here, baesystems.com/GPS. NSF stands behind the BAE Systems company mission. We protect those who protect us. That is our #1 goal. As part of our M-code development, we have several Spirent simulators that we've used in support of the MGUE program, including the development and test guidance systems for precision missions. There are unique challenges in testing such high dynamic applications. Mark Holbrow will discuss some important considerations in the next presentation. All yours, Mark.
Many thanks, Jade, for your presentation and that introduction. A couple of housekeeping parts. I just want to give some thanks to my colleague, Rafael Zawakowski, who has been key in generating the slides for today. And also, I just wanted to make a little bit of a plug, because it's only a brief 10-minute or so talk on high dynamic testing and low latency, which means we're just going to touch the surface of it. So please do look out for a white paper which will be forthcoming in the next couple of months from my colleagues in Spirent Federal, which will be going into a lot more detail and underneath the content that we are speaking about today. I'm also really proud to say that, Spirent have been a key test partner and really played our part in reaching that position where, as Jade said, M-code is ready to go. And further to that, we're also playing a key part, as she mentions about the FMS and those technologies being rolled out to the rest of the world. We're also supporting those businesses and governments in being able to continue their test strategy. So today we're just going to talk a little bit about high dynamic testing and potentially low latency as well. So I've broken these first few slides up into just the different types of high dynamic testing that exist. So in this first case here, we're looking at rapid motion change. So the whole point being able to have a simulation environment in the laboratory where we are accurately recreating rapid motion changes. And it's also worth noting as I go through these slides that when we are producing the simulated signals to recreate that high dynamic environment, that can support all of the legacy GPS signals as well as all the Y and M related signals that we're talking about today. So they just sit over the top. So all the signals that are in space are also being simulated whilst we're in these challenging test environments. So first of all, we have rapid motion change. Further to that, then we look about rapid direction change. So again, in examples like this with the F-35, we are going to be in a lab environment enabling to produce the test asset, which is going to enable us to be simulating the signals which that F-35 would have seen in some very, very high dynamic maneuvers. And we'll also be making those signals representative of what could be either a FERPA or, in this instance, actually a SERPA receiver or SERPA antenna, to also be able to simulate all of the appropriate elements, again, as we are overlaying all of the high dynamic maneuvers which are required in the test arena. The third place is rapid situation change. So you can be building up a whole load of different maneuvers based upon different legs of potential missions that need to be run, as well as then overlaying on that an appropriate RF environment, which can be simulating and being able to put the receiver through various anti-jam and anti-spoof scenarios. So all of those high dynamics need to be brought into the lab environment so that effectively that receiver can think it's undergoing those very fast changes in motion and seeing the equivalent GNSS or GPS signal which would have been seen if it was undergoing those high dynamic situations. This slide is really just talking about how we are taking, in this case the F-35, we're taking 6 degrees of freedom of being able to describe both the linear and angular motion of the vehicle or platform under test. So the user can actually describe in 6 degrees of freedom all of those appropriate velocities, positions, accelerations and jerk terms to describe the trajectory of the of the platform that we are looking to simulate. So as well as being able to capture all of that actual vehicle motion, ultimately we also need to be taking into account the satellite motion which is taking place independently. And then the key thing that the simulator is doing is it's recreating the appropriate signals on a satellite by satellite basis to recreate the appropriate range and range rates in a composite manner which the receiver would see if it was undergoing those dynamics. Really, we just talked about GPS, but ultimately these platforms have also got inertial sensors on there. So again, we're in a situation where the exact same underlying trajectory information needs to be reused, but this time we are placing various gyroscopes or accelerometers in and around the platform itself, and then alongside the GNSS signal being simulated relative to that particular trajectory, we're also recreating appropriate delta V and delta theta informations which are commensurate with the gyros and accelerometers which are placed on the vehicle itself. So that way we can end up with both the inertial sensors and the GNSS signals being supplied and injected into the device under test, all commensurate with the high dynamic motions which are required in the test scenario. Now, key thing to ensure that we are making sure that we are capturing all of the high fidelity and maneuvers and changes in direction or subtle vibrations of the vehicle platform is to ensure that we are sampling the trajectory in as faster and repeatable manner as possible. So as you can see in this simple slide here, as that aircraft makes that trajectory twist, if we're not sampling the trajectory in a fast enough manner, we are just missing various elements of the maneuver. So for many years now, Spirent have been setting the pace of being able to gradually introduce faster and faster system iteration rates, as we call it, and have now just introduced 2 kilohertz update rate, or 2 kilohertz system iteration rate, which means every 500 microseconds, we can be taking a 6DOF set of parameters and evaluating them and producing appropriate corresponding GNSS signals for that particular position, as well as the inertial sensors as well. So in the next slide, as you can see here, where we're sampling that much faster, you have managed to capture that trajectory twist in this instance. Now, again, high update rate, high sampling is only needed in instances where there are these high dynamics to capture. If there's repeatable, benign environments, then lower update rates are okay. But in instances where you're working in real time and there's the opportunity for these high dynamic maneuvers to take place, the iteration rate is absolutely fundamental to be able to recreate the test environment that's required. So on this slide, I'm trying to bring that all together. So on the right-hand side, we have our mission simulator, which is feeding 6 degrees of freedom trajectory information into the simulator. We're then sampling that trajectory information at a higher iteration rate as we can support, which, as I say, at the moment is up to 2 kilohertz. Within inside the simulator, and this is a GSS 9000, what's happening there is we're modeling the satellites, we're modeling the RF environment, we're modeling the antenna placement and the antenna patterns, we're modeling the placements of the inertial accelerometers and gyros, and then we're translating all of that information in either into a delta V and delta theta stream that goes into the device under test, or we're actually generating the appropriate GNSS signals, which again are commensurate with all of those elements I just mentioned, and again are being injected into the device under test. And then the output from the device under test can feed back into that mission simulator to produce a closed loop system. Synchronization between all those elements is obviously very important. And the other piece that's worth noting at this point is that as well as being able to have a fast iteration rate to ensure that we're picking up on the nuances of all the trajectory itself, the other key thing here is that if we think about latency, and latency being the time it takes from sampling the incoming trajectory information to reproducing a corresponding GNSS RF signal which is reacting to that position which we need to reach, the higher and faster the iteration rate, the lower the latency. So in Spirent's latest generation of simulation products, we have instances where we can have as little as 4 iteration steps between sampling the data to recreating an RF event on a satellite-by-satellite basis commensurate with that incoming trajectory. So in that instance there, we're beginning to look at, in the case of 2 kilohertz, 2 milliseconds worth of latency. And this slide is just talking about the scalability of these solutions. In all the prior slides, we spoke about effectively a single platform delivering a GNSS or inertial solution for a single platform. Well, with the complexity of the test environment, the need for being able to simulate multiple elements of a SERPA on a platform, being also at the same time being necessary to actually support both the platform as well as potentially the projectile that is being carried by the platform, and then also then to be able to simulate the launch of the projectile, again is a valid test requirement. So by bringing together various GSS 9000s test assets, the Spirent solution can be scaled to be able to support simultaneously multiple vehicles with multiple antennas all being simulated at the same time. So that concludes my presentation. There's a much deeper white paper which will be being produced by my colleagues in Spirent Federal in the next few months. So please do look out for that one. In the meantime, I'd like to hand back to Aurora.
Thank you, everyone. That was a really great presentation. So at this time, we're going to jump into some questions we received during registration and a couple we got during the presentation. So the first question that I have is for Colonel Solham, and the question is, how will multi-GNSS be implemented in MGUE Increment 2?
Yes, thank you, Aurora. Starting back in FY19, the National Defense Authorization Act from Congress directed the MGUE Increment 2 program to incorporate multi-GNSS signals. That language has been updated in FY20 and FY21. So our Increment 2 program is in compliance with that initial language and making sure that we do incorporate multi-GNSS signals into the Increment 2 program. When it's incorporated, the GPS M-code signal will always have the highest priority for the receiver cards. And the GNSS solutions will only be used when the GPS option is not available. We will maintain signal separation to comply with integrity requirements, and the capability to use the multi-GNSS signals can be enabled or disabled by the receiver software settings. Our default is going to be to disable the multi-GNSS capability and only enable it if the operational community wants it there. And it will prohibit mixing of GNSS and GPS in a solution. Within the Increment 2 receiver, the next generation ASIC that is being developed, it will include, obviously, the 3 GPS signals, L1, L2, and L5, but will also include 2 Galileo signals, a QZSS signal, as well as the SBAS L1 signal.
Great. And the next question that I have is going over to Jade. The question is, what benefits do users get when they adopt M-code?
All right. Yeah, that's the beauty of the Increment 1 M-code technology, is that you get more than just M-code. A lot of people think that by picking up the M-code technology, what they get is one more encrypted signal type. But it's actually a pretty big jump between our SASM-based products and our M-code products, because you get enhanced anti-jam and anti-spoofing technology, increased channels for tracking, and some great performance increases or improvements upon the SASM technology. And the real exciting part is that most of those improvements are applicable on Y-code signals being tracked with an Increment 1 receiver. So why does that matter? Well, we don't currently have a full constellation for M-code signals, so what that means is you get enhanced performance out of these receivers, even if they're tracking a mixed or even all Y-code solution. So I think that it brings a lot of benefit to our warfighters, which is what really matters. Thanks.
Wonderful. And Mark, I have a question coming your way. The question is, what are the top 3 use cases for testing the limits of MGUE and high dynamic testing performance?
Thanks, Aurora. That's a good question. I think from my personal view, based upon some of the test scenarios that I know our partners are creating, probably we see a number of scenarios where there are spinning requirements and high spin rate requirements for projectiles. So that being able to simulate that spin of the vehicle is really quite a complex process, especially when you're in situations when there are some really clever antenna structures in and around the periphery of the projectile. So again, we are needing to model and simulate the effect of how the GNSS signal and inertial sensors are going to be affected as they are received on individual patches on the antenna as the actual antenna is rotating. So obviously you then start running into all sorts of interesting phase, wrap-up type effects, amplitude modulation effects. So that is definitely a high dynamic environment which requires some very specific and advanced test capabilities to support. The other area where I think is a key test space for us is very much in those, as I mentioned, as you saw in the slide there, like the F-35 or other very maneuverable aircraft. So we know that customers are developing their own trajectories to be able to put the GNSS receiver equipment together with the antenna placement, really put it through its paces as the F-35 is doing its really amazing acrobatics. So that's another key area. And I think after that, it's probably all about just launching and the situation of where either a projectile being launched from the ground and or a projectile that's being launched that's being carried on an aircraft or a separate vehicle, and being able to simulate those effects. So I think all of those areas there are instances of high dynamic test scenarios which are obviously very well suited to be done in the lab environment, where you can realistically and reliably recreate a number of different situations without having to be out there in the real world.
Great, thank you, Mark. And Colonel Solham, I do have one more question for you. The question is there a need for a secure custom ASIC?
Yes, thank you. So at this point, there is absolutely a need for the secure ASIC that is custom built. So that is what we've used for the SASM era, the Increment 1 program, and the MGUE Increment 2 program. But there is a lot of interest across the Department of Defense for reprogrammable signals and software-defined radios as user equipment. So in addition to my 2 acquisition programs out of Production Corps, I also have a team that supports the security certification and security approval that ultimately is run by Mr. Dunn and Colonel Colburn. So we have a lot of really smart folks that are assisting other programs in the Department of Defense, like the Air Force Research Lab, who are exploring software-defined radios to figure out if it's possible for us to get to a point where we can security certify and approve those devices and be able to take advantage of reprogrammable signals going forward. Now, certainly software-defined radios will not support every user in the Department of Defense, but there is certainly a niche community that will be able to use those signals if we can find a way to get them security certified. So today, I'll tell you that there absolutely is a need for secure custom ASICs, but we are trying really hard to get to a point where we don't have to have a custom ASIC, but instead could use something like a field programmable gate array or FPGA moving forward for user equipment. Over.
Great, thank you. And we're going to do one final question before wrapping up today's event. The last question is going over to you, Jade. And the question is, how is the DoD acquisition and M-code upgrade strategy aligning with end of life on legacy GPS products?
Yeah, I get this question a lot. People are just trying to field the increment one technology, and they're hearing that the ASICs are obsolete. So what do we do? And both Colonel Solom and I talked about this in our briefs, that the DLA bulk buy is intended to cover the DoD. So I can say that the DoD bulk buy for BAE Systems has been awarded, as I mentioned. The quantities purchased are intended to cover the DoD demand through the end of 2029. So we believe that that is taken care of, allows you to then put together your plans for how you'll adopt increment 2 when it's available, but at least you know that increment 1 will continue to be available. Now, how exactly those are going to be allocated is something we continue to work with DLA and the OSD on. So details are still coming on the exact how, but the most important thing is that it has been awarded, and we will have the base need covered for the DoD through the end of 2029. So don't use that as your excuse not to go to M-Code. We've got you covered, and we're ready for you.
Great, thank you. And thank you everyone for sharing all of your insights with us today. We're gonna go ahead and wrap up the event now. First, I'd like to thank everyone for attending. We appreciate your time. And now I'm going to go over a few closing remarks. Thank you for attending today's webinar, GPS and MGUE Program Update and High Dynamic Testing, brought to you by GPS World Magazine and our sponsor of the event, Spirent Federal Systems. If we were not able to answer your questions during the presentation or Q&A session, your questions will be forwarded to the panelists and be addressed via email. The resources panel houses a PDF of today's presentation slides, which you can download. To access this panel, click the green icon at the far right end of the toolbar at the bottom of your screen. A recording of this webinar will be emailed to you tomorrow and posted to gpsworldmagazine.com/webinars. And upcoming webinars from GPS World Magazine will also be posted to that page. Thank you all for attending, and we hope you'll join us for another great webinar.